Welcome back to another episode of HaugoMATH video. In this episode, we are going to examine exponential relationships and see along the way how they relate to goals in life. Oh, that's a loud clock. So, buckle up and enjoy your experience. Can someone stop that clock? We're trying to do a math video here. Boy, it's getting exponentially louder and louder. We'll just have to move on. It's getting too loud for us here. Let's compare something new with something we've done in the past. Linear relationships. Linear equations have come in the form y equals mx plus b, slope-intercept form. The slope and the y-intercept were very important there. Well, exponential relationships come in the form y equals a times b to the power x. We have an exponent there. A stands for our starting number or initial value. B is the growth or decay factor. When we look at graphs, we see that linear relationships are straight lines, either going up or coming down. Exponential ones are ones that go up or down by curves. Linear tables have a constant increase going up or down by a number. That's where we find our slope. Exponential tables have a constant multiplying factor visible. Multiplying by 2 in this one, for instance, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So a little bit different than linear relationships. So what does this have to do with goals in life? Well, I have a goal in life, and that goal is to be...
You have got to be kidding.
Oh no, this is going to happen. But for it to be a reality, I got to make sure I hit the weight room. So I'll use 3 primary lifts to grow my strength exponentially. Got to improve my bench, improve my squats, and get my shoulders jacked through a bunch of military presses. So I'm pretty weak right now. Hey, that's why I'm going to start training. So I can only lift through my 3 combined lifts a total of 200 pounds. Not much. But that's going to improve really fast. But ironically, some people say that as your strength gets stronger and stronger, your coolness factor starts to go down and you're not as cool anymore. So I guess my coolness rating is going to be decreasing at an exponential rate as my strength is increasing. Oh well, I guess I got enough coolness to start with, starting at a rating of 4,000. And I guess that rating has been rated off the charts. Negative. Let's hit the weights! Yeah! I'm huge! Look at these shoulders, massive! Wow, what a workout. I feel great. So now my strength is going to be increasing. It's actually going to double each week. But on the bad side, my coolness rating is actually going to get cut in half each week. So let's examine what this looks like in terms of exponential relationships. So let's remember that exponential equations come in the form of y equals a times b to the power x, where a is our initial value and b is our growth factor. So let's examine both situations simultaneously, remembering that my strength would be doubling and my coolness would be getting cut in half. So my y variable above is the total weight that I can lift. The y variable below is my coolness rating. The initial value of my strength is 200 pounds and the initial value of my coolness rating is 4,000. The growth factor in my strength increase is 2 because we're doubling. And below, my coolness rating is actually getting cut in half, which we'd be multiplying by 0.5. So remember, exponential relationships, it's repetitive multiplication, and that's exactly why we have these exponents up here, which is our x variable, which stands for weeks. And that just would tell us how many times we would need to multiply by 2 or how many times we should multiply by the 0.5, depending on what I'm looking for. So let's see where everything stands after 1 week. So we'll slip in the 1 for the weeks here and the 1 for the weeks here, and see what we get. So mathematically that would look like this. Multiplying with 1, 2, we end up with 400 for my strength, 400 pounds. And down below, this is what that would look like, multiplying with 1 of the 0.5s, and it drops my coolness down to 2,000. All right, let's hit the weights. Yes, more shoulders, get a little leg burn in there with us. Nice. Oh, what a wonderful workout. Again, I feel awesome. So let's take a look at where we stand now with my strength. So now it's been 2 weeks, so the exponent is 2. We're multiplying with 2 2's, and it's up to 800. Or what we could do is just simply multiply our last result by that growth factor of 2. Same with down below, 2 weeks, so our exponent is 2, multiplying with the decay factor twice now, and we end up with 1,000. Or we could have taken our last result and multiplied by that decay factor of 0.5 to get our result that way. Well, let's hit those weights again. Yeah, let's build up the arms a little bit here, little legs. Nice. All right, workout number 3 done. So week 3, put our 3 in for the exponent. Now we're multiplying with the growth factor 3 times, raising that up to 1,600 total pounds I can lift. Thank you very much. And however, on the downside, the coolness factor is dropping. Change that exponent to a 3 weeks, multiply with the decay factor 3 times, and now we're down to 500. Again, we could have multiplied with our growth factor with this last result to get this, and with the decay factor and the 1,000 to make the new end result after 3 weeks here as well. All right, time to hit the weights again. Let's do it. Whoa! Wow, just got done doing 632 reps on the bench with some dumbbells. 150-pound dumbbells, no big deal. Look at this chest, it's enormous. You park some cars on this thing. Woo-wee! Oh, yes. So, 4 weeks in now. Change our exponent to a 4. Multiplying with the growth factor 4 times. Look at my strength. I can do over a ton of weight now, 3,200 pounds. However, I'm not feeling as cool as I once did. That's all right. So the exponent here, 4 weeks, multiplying with that decay factor 4 times, dropping my coolness factor down to only 250. So again, we could have multiplied 1,600 by 2 to get our new total weight, and I could have multiplied the 500 by 0.5 to get the new coolness rating. All right, time for another workout. I need a change to this workout. Something different. Oh, I just got a great idea. I'm so strong. I just pulled this train for 6.8 miles without taking a break. Man, am I strong. All right, my training is now complete, 5 weeks in. So one more time to the 5th power, multiplying with 5 growth factors, multiplying with the decay factor here 5 times. So my strength it's impressive. I've just impressed myself. 6,400 pounds, but my coolness factor not so good looking right about now. Let's go win that strongman competition. I mean, strong math teacher competition. Before we do that, we better take a look at the finished product here. I am enormous! How could I lose? Woo-hoo! So this is well worth it. Even though my coolness rating dropped to 125, that's okay. An average middle school student's coolness rating is only around an 8, so I'm pretty good. Still. Lastly, let's look at the growth and decay graphs here. Exponential growth is a curved graph line, smooth graph line coming up, and decay is the one that is smoothly coming down. So we can see what makes something exponential. It's repetitive multiplication, like we just saw, and that will start off our situation very slowly and then real rapid increase as time goes on. Same thing with exponential decay. We're going to drop drastically and slowly start to taper that off and slow that down. Lastly, let's be on the lookout during these situations and remember that when you multiply with the number 1, that's not going to change anything. It keeps things exactly as they are. So anything bigger than that is going to result in some type of increase. So a factor bigger than 1, we get exponential growth, like the one that we did today. Growth factor of 2, that was doubling everything. So any of these numbers, even this a little bit bigger than 1, is going to increase our amount with exponential growth. And just the opposite, anything smaller than 1 is going to shrink or reduce our amount. So our decay factor that we had today was 0.5, always getting half of the original amount. 0.999, a factor like this is just barely less than 1. That's going to cause a tiny bit of decrease, not much. So it's something with this type of decay factor, it's going to have a very slow decay. And that's it. So this is Mr. Haugom signing off, wishing that all of your dreams come true as did mine. Have a good night.